I have no idea.
Jacob gonna
I think they're going to Bay. I don't know.
Well, no, I mean like those last 3 weeks after.
Oh, nothing. No, I'm not doing anything with them. All right.
Hold on. I should have started.
They got one. It did, yeah.
Oh. I burnt my pencil last night. I just stuck it in the fire.
Okay, we're going to be hypothesis testing, but this time we're going to be working with 2 samples at a time. For instance, since your SAT scores are coming in, I could make the claim, the average SAT score for Gladstone students is higher than the average SAT score for Escanaba students. I could make that claim. You could take samples of Gladstone, samples of Escanaba, and see if I'm lying to you or not. Or are we significantly better than them? Or is everybody in the normal curve and there's no significant difference? We're looking to see, there will be a difference, your scores aren't going to come out the same, but are they far enough apart to say that there's a significant difference, like something's making one school better than the other one? Or are they in the normal curve and it's just all good? One's a little lower than the other, but everything's in the normal curve. So that's the kind of testing this chapter does, comparing 2 independent samples. All right. So, hypothesis testing for 2 independent samples for the difference in their means. And again, we're working with large samples today. So means with large samples tells us we're going to be using that Z table, greater than or equal to 30. So we're answering when we do the hypothesis testing, we're basically answering the question, is there a significant difference? Because yes, every population is going to be slightly different from each other, but is that difference significant enough to put one out in the tail of the other one? Is there a significant difference? So, it's a 5-step process. So you write the claim. As a difference. So the mean of one minus the mean of the other. The mean from sample 1 minus the mean from sample 2. And then we'll be saying greater than, less than, equal to, less than or equal to, whatever it might be. So we're writing it as a difference. So that's the only thing that is different about this chapter than the last one. We've got to incorporate the 2 samples together. We're checking the difference in them. So after you write the claim, the hole in the ha, you sketch the shaded region. As determined by the ha.
You move it up.
Yep. Find the critical z-score, because we're doing large samples with means.
That's 3 or is that 2?
That's still part 2. Find the critical z. Our third step is to take the sample difference and turn that into a z-score. Convert the sample difference into a z-score. And here's your formula for that. X bar 1 minus X bar 2. So you take that difference in the sample means, and then you take the difference in the population means, as determined by the hope, and then your denominator is the variance from sample 1 squared, or excuse me, the standard deviation squared, which is the variance, over that sample size, and then the standard deviation from sample 2 squared over its sample size. And then 4 and 5 are just like we've been doing. 4 is reject the whole or fail to reject the whole, depending on where your sample lands, and then 5 is say something about the claim. Reject whole or fail to reject whole. And then 5 is say something about the claim. So I have 3 examples for you today. Here we go. Example 1. Claim. There is a difference in the mean credit card charges for the people that live in New Hampshire and New York. And then here's the sample data that they collected. New Hampshire, the average credit card charges for the people, it must be what they carry on their credit card, is what I'm assuming this is, $3,900. Standard deviation, $900. And they took a sample of 50. New York, the mean is 3,500. Standard deviation 500. And then sample size 50. And we're going to test this at 1%. Okay, so again, the claim is a little trickier. That's about the hardest part of the whole process, is writing the claim, comparing the two. But again, the claim is about a mean, the mean difference. So, what they're telling me is there is a difference. So if I was to compare the mean for New Hampshire and the mean for New York, what would I be saying about them if all I say is there is a difference? What math sign says there is a difference between them?
Minus.
Not minus yet. There is a difference. Am I saying which one's higher or lower? No. So what sign can I put in there to say they are different from each other? Not equal to. So that's the way they're saying it, but to test this, we've got to write it as a subtraction, a difference between the two. So it doesn't matter which way I subtract. I'm just going to keep, pay attention to the way I subtract. So I'm going to subtract the mean of New York from both sides. So if I subtract the mean of New York from both sides, and some of you will be able to skip that first step, the mean of New Hampshire minus the mean of New York does not equal, what's left over here on the right? 0. So that makes my claim, this is still the claim, I just rewrote it as a difference, so here's the claim still. And the claim is now which one? Ho or ha? Ha. Not equal to is always the ha, that doesn't change. So the mean of New Hampshire minus the mean of New York equals 0. There's our ho. Okay, now we're ready to sketch the rejection regions and find the critical values. What kind of test are we doing? Left tail, right tail, two tail? Two tail. How much is shaded in each one if our alpha was 1%? 0.005, 0.005. Large samples, our critical values are z-scores. Negative 2.575, positive 2.575. Now we're going to do the sample mean converted into a z-score, and I think I have room to squeeze it in right over here on the side. I'm going to try, just to keep it all together here. So the z-score, and I have to subtract them the way I wrote my claim. And I wrote my claim as New Hampshire minus New York. That's what's important that you set up. Well, not so much on the not equal to, but on the greater than or less than ones. You definitely want to make sure you pay attention to the order you wrote the claim. That's the way you're going to subtract your sample mean. So we're going to go X bar New Hampshire minus X bar New York. So we go to the table. New Hampshire first. The average charge in New Hampshire, 3,900. New York, 3,500. The difference in the means from the whole, what are we saying the difference in the means is here? 0, so we're subtracting 0 over there. We will have one that's not 0 eventually. In the bottom, we need the standard deviation from sample 1, which is New Hampshire, squared over the sample size from sample 1. So 900 squared over 50. And then New York was 500 squared over 50. How good are your calculator skills? $7.5. I agree. Any luck? Okay, so 2.75. Where are we on our normal distribution here? Which region are you in? Fail to reject or reject?
Reject.
Reject the hope. You're over here. What are we saying about the claim? That there is a difference. True or false? Claim is true. So that difference there is significant to say that the people in New York are putting more on their credit cards than the people of New York. New Hampshire more than New York. Okay, try another one. Number 2. AAA. Claims. That the average cost to vacation in Florida is greater than the average cost to vacation in Maryland. We're going to test this at 5%, and here's our sample data. Florida, the average cost, $252. I believe this is per night. Standard deviation, 22. Sample size was 150. Large sample. Maryland, 244. Standard deviation, 18. Sample size 200, large sample. Notice the sample sizes don't have to be the same size. Just as long as each one's over 30. Okay, so again, we're testing the difference in these. So, first of all, the claim is about the average cost. Average is mean. We're using mu. So the claim, and it doesn't matter which one you compare, but it says that the average cost of vacation in Florida is greater than the average cost of vacation in Maryland. So the mean for Florida is greater than the mean for Maryland. Could I have said the mean for Maryland is less than the mean for Florida? Absolutely. But we have to write them as a difference now. You start out with that, but then you rewrite it with a subtraction in it. So I'm going to subtract the mean from Maryland over here. So the claim gets rewritten as the difference, the mean for Florida minus the mean for Maryland is greater than 0. So the claim is still the ha. The whole will be that the difference is less than or equal to 0. Now you go to your rejection region. What kind of test are we doing here? Left tail, right tail, two tail. Ha, greater than, right tail. .05, positive z-score. And have it. Now we do the big ugly plug and chug formula for our difference in the sample means, and pay attention to the claim. I did Florida minus Maryland. So the mean for Florida minus the mean for Maryland. So Florida's first 252 minus the 244. And it's asking me to subtract the difference in the population means from the whole. That's still a 0, till our next example. The bottom is that ugly square root, which you apparently had no problems typing in your calculator. So Florida's are 1 and Maryland's are 2. So 22 squared over 150, 18 squared over 200. Anybody on this one?
3.63.
Yep.
Okay. So that's into the tail, and we are going to reject the hoe. Claim is true. It does cost more money to vacation in Florida because that dang Disneyland's there. Who wants to go to Maryland?
Me.
Eat some lobster.
Set up like the-
Yeah. Okay, last one. Where the claim does not have a 0 in it. Okay, claim. Children spend 9 hours more per week in daycare now, which was 1997, by the way, than in 1981. We'll test this at 1%. Here's our 1997 data. Average time spent in daycare in a week was 20 hours. Standard deviation 6.7. Sample size was 65. Nice large sample. $11.5. Standard deviation 3.8. 70. Okay, the claim's the tricky part on this one. And remember, we're testing the difference. So the claim, and it's about averages because you can see our sample. Nowhere up here did I say the average, but we're comparing averages. So how do we write that children spend 9 hours more per week in daycare now than in 1981? With a difference. So I'm subtracting the two. I'm talking about the average for 97 minus the average for 81. Or I could go 81 minus 97 for that matter. It doesn't matter. I have to subtract the two means. What are we saying that means?
The order?
It is equal to 9. Does this say that that they spend 9 hours more per week in 97 than in 81? Does the sentence say that? If I had done 81 minus 97, how would this sentence have changed? Negative 9. So you can write it either way. Either one can come first, but you just got to know what to do with the number. Okay, so that claim is the whole. So then the ha will be that the difference is not equal to 9. That not equal to tells us two-tailed test. And we had our 1% again. I think we had this on the first one, didn't we? So negative 2.575 and positive 2.575. Now when we go to do our sample, that second part of it actually has a value because the whole has a 9 in it instead of a 0. So our z-score for the 97 average minus the 81 average formula says we'll go 20 minus the 11.5. And the difference in the population means they're telling me is 9. I don't know what they actually were, but I know what the difference is. And then the bottom. Negative. What'd you come up with? Anybody?
Negative 0.528.
Okay. So that's just off of the mean here. So we're going to fail to reject the whole. And what we're going to say about that claim? Not enough evidence to say it's false. Okay. Stat. Page 373. Yes. 21. I think I'm going to go with that.